Okay, we're talking about 2016, number 6. Okay, so on number 6 here, we're given a table with some original function values and some derivatives. And it says the functions f and g have continuous second derivatives. Okay, the table above gives values of the functions and their derivatives at selected values of x. For part A, let k of x equal f of g of x. Write an equation for the line tangent to the graph of k at x equals 3. So there's kind of two things going on here. First of all, how do you write the equation of a tangent line? And second of all, how do we take the derivative of k? Okay, which rule are we going to be needing to find the derivative of k? So let's see here. Let's start this problem. So for part A, in order to write the equation of a tangent line, I need an x value. In this case, it's 3, I think. Yep, at 3. And then what we're going to do is find a y value by taking 3 and plugging it into k. So f of g of 3. Okay, so first what we'll do is we'll find g of 3. G of 3 is 6. So f of 6 now. F of 6, remember how to use your tables. F of 6 is 4. Okay? So k of 3 is 4. So now I have an x value, I have a y value, now I need a slope. So to find the slope, we'll take the derivative of k. And for the derivative of k, we're going to need a chain rule. So take the derivative of the outside, but keep the inside, and now multiply by the derivative of the inside. And what we'll do is we'll plug in 3. Okay. So k prime of 3 is equal to f prime of g of 3 times g prime of 3. We're just going to pull all these numbers from the table. So I think g of 3, like we found out earlier, g of 3 is 6. Okay, so we're going to put 6 there. G prime of 3 is 2. Okay, so that's going to change into a 2. And then f prime of 6 is 5. Okay, so now I've got 5 times 2, which is 10. Okay, all right, so to write the equation of the tangent line, we're going to take y minus 4 equals 10 times x minus 3. Okay, we can leave it just like that. Part B. Let h of x equals g of x over f of x. Find h prime of 1. What rule do I need to take the derivative of h? If you guessed quotient rule, you are correct. So, taking the derivative of h, low, times the derivative of the high, minus the high, times the derivative of the low, all over low, low. So f of x squared. Okay. And what we're going to do is we're going to plug in 1. So h prime of 1 equals f of 1 times g prime of 1 minus g of 1 times f prime of 1 all over f squared of 1. Okay, so let's figure out what f of 1 is equal to. F of 1 is negative 6. So we're going to change the f of 1's to negative 6. So this would be a negative 6, and in the bottom I'd end up with negative 6 squared. We'll do them in order. So now g prime of 1. G prime of 1, g prime of 1 is 8. Okay, so I would change that now to an 8 minus g of 1. G of 1 is 2. Okay, so let's change that to a 2. And then f prime of 1 f prime of 1 is 3. Okay, so let's try and simplify this as much as we can. I'd end up with negative 48 minus 6 over 36. So negative 54 over 36, and I try and reduce this as much as I can. Right off the bat, it looks like 9 divides into both. So negative 6 over 4, which is just negative 3 halves. So I started by dividing by 9, and then divided by 2. Okay? Try and reduce it as much as we can. Okay? All right. Part C. Evaluate the integral from 1 to 3 of f double prime of 2x dx. 1 to 3 f double prime of 2x dx. Now let's think about what an integral is, right? What is an integral? An integral is the antiderivative. So if I have f double prime and I do an integral, that's going to take me back up on this ladder of functions, right? So it would take me up to f prime. So the antiderivative of f double prime is just f prime. But what I might do on this one is I might do a u substitution. Okay, so let's go ahead and do a u substitution on this one and let u be 2x. Okay, reason being is just so that way we make sure we take care of this kind of chain rule, this nested function of 2x. That makes sure we kind of cover all of our bases. Okay, so let's let u equal 2x. So the derivative of this is 2 dx. So I've got the 2x taken care of, but I need to get the dx by itself. So what we're going to do is divide by 2. And now I've got the dx by itself, and that can be replaced pretty easily. I'm also going to go ahead and change my bounds. I think it's easier if we can just change everything to be in terms of u, finish the problem, then we never have to go back to x. So u of 1 means 2 times 1, which is just 2. And then u of 3 is 2 times 3, which is 6. Okay, so my new integral is the integral from 2 to 6 of f double prime of u, and then the dx is going to change to 1/2 du. Okay, so let's go ahead and integrate. I'm going to go ahead and pull out the 1/2. 2 to 6, f double prime of u du. And the antiderivative, like we said, of f double prime is just f prime. So this one will change to f prime of u, and we'll evaluate it from 2 to 6, but it's still going to be 1/2. Okay, so f prime of 6 minus f prime of 2. Let's go up to the chart to get those numbers. F prime of 6. F prime of 6 is 5. F prime of 2 is negative 2. So I'm going to take 5 minus negative 2. Okay. 5 minus negative 2 is 7, so this would be 7/2. Okay? All right, let's talk about points. This one's not so bad, huh? On part A, you're going to get 3 points total, 2 points for the slope at x equals 3. So the reason they're giving you 2 points is because of that chain rule. Okay, so make sure it's kind of an all or nothing on this one, so you're either going to get your 2 points or you're not. And then 1 point for the equation of the tangent line. On part B, you're going to get 2 points for applying the quotient rule. Okay, your expression for h prime of 1. All right, and then 1 point for your answer. Again, if you didn't reduce it, if you listed out any of these 3 numbers, you would still get your point for that. You don't have to reduce the fractions, but I would still encourage you to if you don't feel like you're too stressed on time. Okay. On part C, you're going to get 2 points for the antiderivative. So because I kind of did this work a little bit differently, as long as I have all of this and that 1/2 there, then I'm going to be fine, right? So this would get me my 2 points. Okay, and then 1 point for your final answer. Okay? All right, let me know if you have any questions.